cost function. Actually, the second part is easier than first part. But many students, if you do not understand the query optimizer, especially the cost-based query optimizer, project B definitely you cannot do that. Project B1, task 1 you can do without understanding. You can just create the table and insert the data, that's it. However, without understanding cost-based optimizer and each cost function, it's not easy to implement it. Okay, so we will see each of them. So how can we calculate the cost as we discussed before? Where is it? Access cost to secondary storage. And there are more storage costs, computation costs, memory usage, communication costs. We will select only the first one, access cost to secondary storage, which is the same as what? Number of I/O. Okay. Is it given? No. You need to estimate. Okay. Think about for example, if employee, this is just an example. Employee has the 100 data. Okay, you are using the database block. What is a block? In operating system, in database, what is a block? Block is
like a record of data?
It's the I/O unit. So when you read the data from computer operating system, so I need only 1 byte of data. Does the operating system return only 1 byte of data? No. It returns 1 block where the data is stored. It doesn't matter, so 1 byte, 2 byte, entire block that include, so for example, it's a 512 byte block. Okay, then I need only this one data, return the only 1 byte data? No, entire block will be returned. It's a minimum, the unit. It's a basic unit of input and output. The database is the same. Even though I need 1 record, however, entire block that include the record or data will be returned. Database block is usually larger than this operating system block. Sometimes 2K, 4K, up to 16 megabyte, 32 megabyte. Nowadays, big data system, I'm not sure whether you heard about the big data system. Okay, big data system use 64 megabyte and 128 megabyte the block size, which means even though I read only 1 byte of data, entire 128 byte will be returned. Why?
It's a block. It's a block. It's a block.
Yeah, it's why you use block, not byte by byte.
For the access cost? For the access cost?
To be
Cost,
easier.
which means performance. For example, not always I need 1 byte of data, usually next to each other. Think about your programming. Program is what? Instruction, sequence of instruction. Higher chance to access the next instruction. It's not always the next contiguous, but higher chance in the next. So entire block may be used again. That's what? Heat ratio that I mentioned at the beginning of this class. That is the reason heat ratio is actually very, very high. So if I return the byte by byte data, costs a lot. So because of the cost issue or the, what is that? Performance issue, we will use the block. So we need to decide the number of block to access the employee. 100 record, each record has 10 bytes of the data, which means how many total size. It's not accurate data, it's a rough data. Okay? Maybe it's changed to today and the tomorrow, but it's the rough data. until you update such an information. Okay, so it's a 1000 byte. 1000 byte. If we are using 512 byte, the block. How many blocks do you need to keep this one? 512 byte. This is a 1000 byte. 2 byte. So you need 2 IO to access input. Okay, that's the basic idea how to compute the cost count number of IO. Yes.
So you said you need 2 byte or 2 blocks?
2 blocks. 2 blocks. Okay, it's a blocking. We will see detail such an example. So we will consider only the access cost, the secondary storage. That means number of IO. Okay. Then the other we can ignore. Even real DBMS system they ignore the other part, only the estimate the number of IO based on the secondary storage. Yes.
So don't worry about that.
If we want. So no, it's not practically impossible. It's impossible. Okay, it's not possible practically to implement the other cost. Okay, not easy. Then, anyway, this is just one example. We need to consider many different information. So first, I'm going to explain about the notation that we are going to use. So half of the student actually give up from this slide. Okay, pay attention to the notation first. It's not very new one or the complicated one. It's I know sometimes the student can understand when I describe or from the diagram. However, when they try to read such a notation, especially mathematical notation or mathematical equation, it's frustrating. Right? So, however, usually when from time to time I help my son, my daughters, the math, because my major was mathematics education. I try to be a high school math teacher, so I do not give up yet. Who knows? I will be the high school teacher. So if I am fired here, anyway, I'm not sure whether salary is better than here. Actually, if I cannot get the job offer in the United States, I try to return my hometown. Then I try to have a business to teach mathematics in English. Yeah. You know, most of the East Asian countries, the South Korea is crazy to learn the English. Also, the math, the score is the most important part to enter the college. So if you can teach math in English, it's the best way for business.
I don't know.
Seriously. So last winter I visited China. China is the same thing. So a lot of the private kindergarten they actually take care of the kids in the kindergarten in English. That's very expensive. Very expensive. So it's almost 10 or 100 times expensive than the public, the kindergarten, right? So why don't you think about that?
Yeah.
You can have the global business. Anyway, but the problem is it's not easy to find a certified teacher. Okay, so government they actually would like to hire the certified teacher, so which means you need to get the certificate or the degree, like it's a TESOL program. UB does not offer, but the offer such a program, like the teaching at ELI. Anyway, but when I have the math, the first thing I mention every time actually is math equation is kind of a language. It's a natural language. So what is the most difficult question? It's the problem solving in math. However, problem solving usually a lot of description. It's ambiguous. It's not clear. But mathematics is a simple and clear and perfect once you understand. Like for example, instead of explaining about the Pythagorean theorem, like the C, B, A squared D squared is the C squared. So this one is, that's it. It's a true, it's applied the universe. It doesn't matter where you are, so it's a true. Even if notation may be various. Like the area use different notation, different alphabet, but Pythagorean theorem itself is not changing. Universe is a true. Not really is true, it's under Euclidean space, the Euclidean. But in your case, think about the surface of the earth, it's not flat, it's actually surround, right? So that is not true in the non-Euclidean space. But anyway, it's a different story. So don't be frustrated when you see such a notation. If you once you get used, it's much easier than the discriminant. First one is the number of record. We should know how many records for each table, like the 100 in the employee, and record size. Then we can multiply to get the total size of that, and also number of blocks as we calculate here. To do that, we need to know the block size. Then this one is the most important one, blocking factor. What does that mean, blocking factor? For each block, how many records on average? Okay? In this case, blocking factor for employee with this condition, that is 2 point something, right? 2 point something, which means we are the giver, the decimal point, so it will be the floor, the blocking factor based on the floor, which means it's in this case it's a 2. Okay, so blocking factor means average number of record. Okay, for each block, how many records? So blocking factor may be various depending on the table. Okay, so if we know the blocking factor, in this case 2, we can easily calculate how many times of the I. So that is the notation for use for the file. Okay, then other information for the indexing. Indexing is another data structure to access the data very fast. At the time, most of the index we will see later, like the tree structure. They are organized. Like the less than 10 goes to here. So 5. And less than 5 goes to here. Right? So number of I/O will be determined by what? Level. Right? Level of index. Level of the tree structure. Okay? Can you remember that? Why don't you recall? In case of B plus 3, B stands for what? Balance. Why balance? Levels, if levels are different, like the extremely skewed data, how many are you? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Which one is better? This one and this one. Skewed or balanced? Balanced is better. Why? Query optimizer need accurate data. This one, sometimes 10, sometimes 3. It's not so good to decide. If the average travel time with I-95 is sometimes 5 hours, sometimes 1 hour. And MTA is usually 1 and a half, 15 minutes. Which one is better to make the flight? Train. Even though sometimes it's slower than I-95, if you drive at 200 miles per hour, I-95, then you love it. However, on average, most of the time, MTA guarantee. Which one is better to make the flight? Definitely MTA. Same thing. So we need a balance. That is the reason it's called the B2 index. We will see details the next week. So at this time, how can we determine the I/O? Levels of 3, degree of 3. So that is X, number of level. Okay? And number of first level index means B plus 3 index later we will determine this leaf node. Did you learn the tree structure in your algorithm class and the data structure course? Definitely, I think so. Then this one is called leaf node. B plus 3 include the leaf node, include the indexed data in the leaf node. block is important to access the data. We will see why. Just memorize right now. I will explain later. And number of distinct value. Okay? Number of distinct value is important. Like which one is the best way to access the data? Primary key, because it's unique. What about department number in employee? Department number 1 has 100. Department number 2 has 200. On average, 100. You need more blocks to access. So how many? The distinct value for each attribute. Selectivity on an attribute is, selectivity means how the data are distributed. Okay? Like for example, which one is better to design, to make the plan? Like the primary key is the uniformly distributed. How many distinct value for each? 1. Okay, 1 value for 1, 1, 1, 2, 2, 2, 3, 3. It's so unique. Sometimes the department number 1, 2, 3 is 100, the 10, 300, or 2. Which one will be better to make the plan? This one is better. That distribution is called selectivity. When you access the data, what is the percentage, average? This one is, for example, 1% selectivity. This one is average 20%, the selectivity. Then, using selectivity, if you times the selectivity with the number of record, you can calculate when you access, for example, select from employee, where D number is 1, you can guess how many data are returned. For example, selectivity is 20% and total number of I/O is 100. How many data will be returned? 20. Okay? Because it's 20%. Not exactly 20. Sometimes 100. Sometimes 10. But on average, selectivity determines the average. Anyway, to know the exact travel hour to Manhattan, what is the best way? You need to travel. Do you want to do that? Before you travel, you travel. That doesn't make sense, right? You need to guess. The best guess, educational guess, experience guess. So this one is the guess to how many blocks I/O are needed using selectivity. Okay? So that is the notation then. First, how many more minutes? Neymar, how many more minutes? 5 minutes, okay? 7 minutes? Okay. So, we did most of the prerequisite to learn about the host function. So, for each, do you remember S1, S2, S3? For each table, to travel to Manhattan, how many different ways to access? Like you can travel to I-95, and also you can access MTA, you can access the express train, you can access the JFK. So just like that, we have different ways to access the table. And for each, we are going to calculate the host function. Host, formalize mathematically. So first, we did before linear search. What is a V? Can you remember that? What is a V? Take a look at what is a V? Number of blocks. Blocks for what? To access the data table for each table. So this one, linear search is the brute force way. So how many blocks do you need to access? Last time when we talk about the host, we mentioned the number of tuple, number of data, n. However, from now on, we will consider I/O. I/O is based on block, so B is number of blocks for each table. Okay? So for example, in this case, so how many blocks do we need? 2 blocks. Okay? 2 blocks, so cost is 2. 10 blocks? Yes, 10. However, that is the inequality condition. In other words, if your query is, so, for example, select SRS from employee. Okay. Where in this case, we don't know when we are going to stop. We need to check from beginning to end, right? The last one, maybe. We don't know which one is which. At that time, how many blocks do we need to access?
B block.
B blocks, okay? All entire table. What if this one is changed as the equal? Same, however, we can stop once we find this one, because this is a primary key.
Right.
We can stop. So if we are lucky, we can stop the first block. If we are not lucky, we need to go through entire block B. So on average,
Oh.
B over 2. So it depends on query. Depends on the column. So in your implementation, you need to decide, once you recognize where condition and column, check the catalog table, whether this column has primary or unique or even index. Then check in case of the equality condition, then you can apply the this cost function. Otherwise, you can apply the this cost function. This is one option. It may have different option, right? So then at that time, compute case 1, case 2, case 3, then select lowest one. So next one is, let me go through the other one, binary search. When can you use the binary search?
We have sorted data.
When table is, there's no index, but table is sorted by the key. At that time, you can use like the page number on your textbook. How can you search? Cardinal hop, cardinal hop, cardinal hop. It's a log B based on 2 because we cardinal hop, right? Then what about this one? This is for, actually,
That's the ceiling.
it's a ceiling. S, what is the S?
Selection cardinality.
Selection cardinality, which means on average, how many data are returned? Okay? Like the 20%, the 20 data in this case. Okay? Why? Because this is a general search. Once you find, using binary search, I find this one. And bigger than 185 pages, then you need to search all of this because it's inequality, right? So that it can be computed by, the selection cardinality, but divided by blocking factor because we need number of IO. At that time, -1 means because we apply the ceiling, okay? The worst case, the least case is only one key, equality, unique key. At that time, we don't need. So for example, 1 minus 1 is going to be the 0, so log B based on 2. So in our implementation, actually, we do not consider binary search. Why? We do not use binary search to access the data because we have index, the B3 index, B plus 3 index. So this is just to keep your mind, so we can compute the binary search, but practically we don't implement the binary search because we are not using. What if we have the primary index? Then we definitely primary index, like the social security number. This one has the index, like this one. What is the level? X, 3. So 3 plus 1. Anyone? Why we plus 1? It's a 1, 2, 3. 3 levels. So So 3 might be enough, but it's a plus 1. Anyone?
To prepare for the next level.
Next level is the last level. This is an index. We want to access table. Okay? So which means this one point this one point this one point this. How many IO? 1, 2, 3, 4. One more IO to access the real data. Okay? So in case of the indexing access, you need to always plus 1. Okay, that is the data block actually. So x plus 1 means 1, 2, 3 level plus 1 more. That is the primary index. Hash key actually very complicated. So we just simplify 1. So in your implementation, ignore the hash key. Okay, hash key, we do not use a hash key to access the data. The next one is index plus multiple record. Multiple record means, so once you find this one, you need to access all next one. If we are lucky, first block, the last block. If you are not lucky, you need to access all table, block, b divided by 2. Okay, so x plus b divided by 2. The clustering index for the multiple record means it's a clustering index, so it has the x. Okay, x plus that one has something 20%. So D and O is equal to 1. 1 will return how many employees? On average, 20%, for example. It's a selection cardinality, 20%. So that is the selection cardinality divided by buffering factor. How many blocks? It's a ceiling. Then you can understand. The most frequently used one is the B3 index. B plus 3, B3 index, we will see difference later, but this one is the same thing. 1, 2, 3. The level, x plus, then how many? So for each, it is actually the link, the number of return data. It's a selection cardinality also. So selection cardinality, it will be S, so x plus S. Okay? And then, this one is range curve using. I know this is not easy to understand, so without learning. So once you complete the first level, first task of the B, next week we will discuss about the B3 and B plus 3. At the time you will understand the, more clearly. But this time, this is using B plus 2 index, actually we can travel along the leaf node. We don't have to access every time. So that represents the first level block divided by 2. We don't know how many, first one or entire block, that is divided by 2 on average. And for each record, it's divided by 2. So that is the reason x plus B first level block divided by 2, and the data block, the number of record divided by 2 in case of the range query inequality. Then conjunctive is simple. We apply the S1 to S6, the select the lowest one in case of n. Many conditions. We can select one of the best way. Okay? Then finally, in case we have the query like this one, select employee using social security number, we can apply the brute force way, divided by 2, and or using B plus 3. This one is smaller than this, so query optimizer select the B plus 3 as a 6. That's the fastest route. We will explain. We will discuss one more time later, so don't forget to bring it back. Okay, this one will be used a lot the next class, and also it's very important for the project B. Okay, so please review one more time today's lecture and read what understand the cost function before you come to class. Okay, we will see you next year. Next class.